Hi, and welcome to section 2 of the course where we're going to be given an introduction to MATLAB Simulink before we move into how we can use it for science and engineering. So in this first lecture, we're going to be talking about what MATLAB Simulink is, and we'll talk a little bit about some of its uses in science and engineering. So let's jump on the computer and let's see how we can use MATLAB Simulink.
All right, so let's first talk a little bit about MATLAB and what it is. So MATLAB is a numerical computing environment, and it's also a proprietary programming language that's developed by a company called MathWorks. So MathWorks makes both MATLAB and Simulink. And within MATLAB, what you can do is you can do matrix manipulations, you can do plotting of functions and data, you can implement algorithms, you can create user interfaces. So it's a very versatile sort of programming language that is commonly used in both science and engineering. And in fact, I know that when I was getting my undergraduate and graduate degrees in electrical engineering, we used both MATLAB and Simulink quite a bit for different applications. So we'll go through some of the applications throughout the course, but what I just want to show you here real quick is just a quick example of things that you can do within MATLAB. So what you see here is what's called the command window of MATLAB. And in here, basically you can type commands and MATLAB is going to compute those commands and give you answers. So this is kind of like a programming software, but not really. These are more really commands that you give MATLAB for certain functions, and then it performs the functions that you're telling it to perform. So for example, the commands can be as simple as you say, for example, 5 times 10, for example. So 5 asterisk 10, and you just hit enter, and it gives you the answer. So 5 times 10 equals 50. So the commands can be just as simple as that. You can use it as a simple calculator, sort of. But of course, you can do more complex things within MATLAB. So for example, I can define a vector, for example. So I can say that I'm going to define a vector called x, and that's going to start from 0. It's going to be spaced at intervals of pi over 100, and it's going to end at 2 times pi. So basically what I'm doing here is I'm defining a vector. I'm calling that vector x. That vector is going to go from 0 to 2 pi, spaced linearly in intervals of pi over 100. So if I click enter here, you'll see here on the right in what's called the workspace that I've defined a variable called x, and that x is a double that has 200 values in it. And of course that makes sense because I defined my vector to go from 0 to 2 pi, and the spaces are pi divided by 100. And don't worry if this doesn't make sense for now. We're going to go into this in more detail later on. But I just wanted to show you real quick some of the things that you can do within MATLAB so you get an idea of what you can use MATLAB for. So the other thing that I can do then is that I can say, well, I'm going to define another variable called x, or rather y, and that variable is going to be equal to the sine of x, which I already defined previously. So of course, these go in order. For me to tell MATLAB that I want to define a variable called y, and that variable is equal to sine of x, I would of course have to have defined x first. For example, if I call this sine of z, and I haven't defined z yet, and I hit enter, MATLAB is telling me that we have an unrecognized function or variable called z, because again, I haven't defined z yet. So again, I can do y equals sine of x. So sine of x. And because I already defined x, once I hit enter now, MATLAB also defines y over here. And again, that's going to be also a double with 200 variables. So essentially what MATLAB does is it knows that I defined x as being a vector from 0 to 2 pi in intervals of pi over 100. So it has 200 values for x. So when it computes y as the sine of x, because x is a vector itself of 200 values, then y must be a vector of 200 values. And again, don't worry too much about for now if you don't understand this. We're going to go over this in more detail later on. But one thing that I wanted to show you here is that now that we've defined x and y, now I can say plot x comma y, and MATLAB is going to create a plot of x and y. So if I hit enter, you'll see now that I have here my plot. So again, x in here I define as a vector from 0 to 2 pi, so roughly from 0 to 6.18. So you can see here that this plot goes from 0 over here to 6.18 roughly over here. And again, I plotted x comma y, and then y is the sine of x. So we would expect then the plot to be essentially a sinusoidal function for the values of x going from 0 to 2 pi. And you can clearly see that here. So again, I just want to show you real quick some of the things that you can do in MATLAB. We're going to go over in more detail later on about some more things that we can do with MATLAB, but I just wanted to show you real quick some of the things that you can do within MATLAB. Now, Simlink, on the other hand, is a MATLAB-based graphical programming environment, and you can use it for modeling or simulating and analyzing multi-domain dynamical systems. So what this means is that Simlink is essentially sort of a MATLAB-based graphical interface. So you can do, or rather build models within what's called Simlink, and behind the scenes, Simlink is running MATLAB commands to give you a simulation in a graphical way. So from the MATLAB command window, you can simply type Simlink and hit enter, and that's going to launch the Simlink application. So in here I can say go to a blank model. So essentially I'm going to create a blank model here in Simlink, and of course it takes a little bit to launch the application. But again, Simlink is essentially just a graphical way of modeling dynamical systems, and behind the scenes Simlink is running MATLAB commands to run a model. So for example, here I have just simply a blank model. I can go to what's called the library browser, and again we're going to go over all of this in more detail later on. But essentially from here I can add things like, for example, I can add an electrical circuit. So I can say add an electrical source, so like an AC voltage source over here. I can right click and hit add block to model. I can add electrical elements such as, for example, a resistor, so this one over here, and let's say that I want to add also a ground, for example. So now if I go back to my model, you can see here that I essentially have the blocks that I added. And again, we're going to go over this in more detail later on, but I just want to show you what Simlink looks like. So I can build an electrical circuit essentially over here by connecting my voltage source to my resistor and my ground over here. And then I can simulate this electrical model within Simlink. And again, Simlink kind of works in tandem with MATLAB, and it's running the commands, or it's rather creating commands that match the Simlink model, and then it runs the simulation for the Simlink model. So just like we have here, for example, an electrical circuit, we could also have mechanical systems, we can have hydraulic systems, we can have many different types of systems in different domains. So we can have electrical, mechanical, fluids, thermal, that kind of stuff. So that's what we mean when we say that Simlink is a multi-domain dynamical system model. All right, so let's talk a little bit more about some of the applications for both MATLAB and Simlink. So one thing that we can do to see some of the applications is we can go to the MathWorks website. So let's go ahead and do that. I have over here my website browser, and you can go to MathWorks. So again, MathWorks is the company that makes both MATLAB and Simlink. So in here, just click on the MathWorks website and go to products. And of course, here you can see MATLAB and Simlink are the two main products from MathWorks. So if you scroll down, you can see here a bunch of applications that you can use MATLAB and Simlink for. So for example, we have signal processing, image processing, control systems, test measurement, RF and mixed signal, wireless communications, robotics, FPGA, aerospace, automotive. Of course, we have electrical, mechanical, many different types of applications for both MATLAB and Simlink. So if you want to learn a little bit more about some of the applications, you can scroll through this list, maybe click on a few of them. So for example, let's click on this control systems toolbox, and you'll see here how you can use the control system toolbox within MATLABSimulink to design control systems. So again, MATLABSimulink is a very, very commonly used software for both science and engineering applications. Again, I know that for my case, when I was going through undergraduate and graduate electrical engineering degrees, I use MATLAB and Simulink extensively for different applications, from modeling simple circuits to creating control systems to modeling power electronics or power systems, many different applications. And again, Simulink is a multi-domain software, meaning it's not just used for electrical engineering like I did in my case, but you can also use it for mechanical, thermal, hydraulic, and many different domains within engineering.